with EE Times, and welcome to this latest edition of Silicon Grapevine, brought to you by Synaptics. And today, my guests are some wonderful people in the world of AI models. We've got Pete Warden, who's the founder of Moonshine AI. Hello, Pete.
Hey, how's it going?
Good. And we've got Evan King, who's a founding engineer at Moonshine AI. Evan, hello. How are you?
I'm doing well. Thanks for having me.
Well, good. Well, in this, we're going to talk about some of the things around making edge AI models a reality. How do you make them real? But before we do that, I mean, it's always useful to know the people behind the speaking. And I'm going to maybe get a little bit of your background, Pete. And you've got quite an illustrious background in the industry. And from what I know, from stuff I've done with you, you like to speak out and say what's necessary to be done. Just give us a little bit of your background.
Yeah, definitely. So I've been a professional engineer, software engineer for almost 30 years now, which is terrifying to me. Uh,
And you started under Steve Ferber, didn't you? Learning
yes,
in
I
the
actually
University of
started
Manchester.
studying at the University of Manchester, and I can't imagine having a better teacher than Steve. Like what I've realized since I left Manchester is very few colleges actually have that combination of software and hardware. Like it really was a full stack education.
Mm.
So I've stayed in touch with Steve. It's and he really kind of set me on the course for my career. So yeah, I can't say enough good things about him.
I mean, that has to be good because, Steve set the course for companies like, well, mostly ARM, but yeah, it's pretty good. Now, tell us what else. I mean, you've been like Apple, Google, you've done
Yeah,
lots of interesting
exactly.
things.
Apple, I sold a super early stage startup to Apple back in 2003. My biggest fear was that Apple was about to go bust. Um, and I stayed until 2008 because obviously, 2008, I could tell Apple had peaked. So yeah, and then I was working on startup stuff, and around the AlexNet, when AlexNet first came out, it blew my mind.
Oh,
And
okay.
the startup I was working for was doing, or I founded, was doing image recognition. And as soon as deep learning came out, I immediately grabbed it and started implementing my own runtime to run it, which ended up releasing and was doing deep learning on phones back in like 2013. Um,
Wow.
yeah, and that was really fascinating. Um, and ended up getting bought by Google. Um,
As you do.
yeah, exactly. And I was one of the few people at Google who had done any sort of deep learning outside of the cloud. So when Jeff Dean was getting the team together for TensorFlow, um, I became the person who did all of the stuff that wasn't GPU based. I became the tech lead for on-device ML with TensorFlow. And I was in that role for 7 years at Google.
Wow. Wow.
And my favorite part was that I got exposed to literally hundreds of teams implementing AI in real products, both inside Google and outside Google. Um,
Right.
so I was
That's valuable experience, really, for what you're doing now.
abs-
Yeah. Yeah.
absolutely, I got to learn so much about what actually works in practice and
Mm.
what the real challenges are. Then I left Google now about 3 years ago to really focus on doing local AI and on-device voice.
Indeed, and in that transition to Moonshine, you had useful sensors, and that you transitioned to Moonshine AI, I guess. What was the reason for that?
Well, the first couple of years, I've always had this dream of having voice interfaces for everyone in
Yeah.
anything that's got a switch or a button. And the first couple of years, I thought, oh, well, let's do that by actually having a little hardware module that can be just like a switch, except
Yep.
it's a voice interface. Um, Turns out hardware is hard. And
Who knew it?
yes, and trying to persuade, these traditional companies to take in a new hardware component, as well as, this whole new idea of like having a voice interface on their washing machine. Yeah, that was a terrible idea. So, but while we were doing that, we built up a lot of models and a lot of software for running voice on very constrained devices. And that's my co-founder Manjanath, created the Moonshine models, and I liked, it became such a core part of our business, and I liked the name Moonshine. But since we'd moved away from doing hardware, um, we rebranded to Moonshine AI, but it's the same company.
Okay, very good. I mean, before we go on, I'm going to ask Evan to come in and tell us a little bit about himself and how he got hooked with you. So, Evan, tell us your little journey.
Yeah, sure. So I've been working in software for about 7 or 8 years. I grew up actually in like a semi-rural part of New Mexico, just outside of Albuquerque, and my mother owned a business, and my dad was a civil servant. And in Albuquerque at the time, if you graduated from a high school with a decently good GPA, you pretty much auto admitted to UNM. And I didn't come from a background where I really understood like, oh, you should be doing college applications and stuff. So I just sort of ended up at UNM, which was very lucky for me because I built some good relationships with some mentors there. And after undergrad, actually started as a scientist at the Air Force Research Labs, where I started my career. So um, I was working on low Earth orbit satellites, and they were running very resource constrained hardware, right? Because
Mm,
if you're going to launch something up in space and you need it to be able to, withstand some ionizing radiation flying through it and stuff, that's not quite the same as stuff that we can use on the ground. And working there, I really developed an appreciation for like the constraints you have to deal with, right? When you're building, kind of, you want the full application, but you need to put it on something that doesn't quite have the same resources that we're used to when we're building stuff on the ground or using cloud compute and stuff like that, right?
right, right.
Um, I was surrounded by everybody there had a list of acronyms after their name, PhD being one of the most common ones, and that made me realize, well, if I want to continue this kind of applied researchy sort of track, I should probably go to grad school. And so
Yep,
I went off to UT Austin and I studied under Christine Julian, who's now the department head of CS at Virginia Tech. Um, but I spent 4 years in my PhD at UT Austin, and there I was working on more kind of edge AI type stuff, but in the domain of like smart devices and smart
mm,
spaces. So creating
mm,
um, creating models and creating kind of the integration and the model sort of working in both of those spaces. How do you create devices, voice interfaces that are really intuitive and that have a good ability for natural language understanding?
yeah,
So I published some work there. I published one of the original papers, kind of integrating LLMs into smart devices. Sort of now Alexa and Gemini and Siri and everything are sort of
yeah,
integrating these ideas, right?
yeah,
I I was lucky to get there pretty early, and I remember making a post, I think back in 2023 or something, about kind of the little quick project I had hacked together, which eventually became my dissertation, right? Putting LLMs in smart devices and smart spaces. And Manjanath, who is Pete's co-founder, saw it and sent me an email, and I was like, "Well, who's this guy?" And then I started looking. I was like, "Oh, Pete Warden. Okay. Oh, Manjanath. All right. I know these people. I've read their papers. I'm familiar with TensorFlow." Um,
yeah.
and so I was like, "Yeah, sure. I'll come on board. That sounds great." And so that's how I actually got started at what was originally Useful Sensors, now Moonshine. Was just making a random post on a message board and getting an email like, "Hey, this looks cool. You should come work with us." So yeah, I've been working with Pete and Manjanath and the rest of the team for about 2.5 years now.
What's the biggest surprise, joining Pete and learning about some of the stuff that he's had experience with?
That's a really great question. So, obviously, the technology knowledge that Pete and Manjanath have is incredibly deep, and so I've learned a lot from that. But coming from a relatively modest background, I remember one of the first times. So I live in LA now. I was in Austin when I
Mm,
first started, but I go out to visit and work in Mountain View pretty occasionally. And I remember one of the first times I was talking to Pete in person. He was like, would you ever start like a startup?" And I had never really thought about it before because my dad was a civil servant. My mom, of course, owned a business, but it was kind of a restaurant art gallery type thing, very different than tech, right? So I didn't really have an intuition for how all that kind of stuff works, right? Like what's a VC, what's a funding round, what's a Series
got it.
A,
Yeah, yeah.
and so I think actually the biggest surprise and the most stuff that I have learned through this experience, being a little small town boy or whatever, is just all of the intricacies of how the startup world works. And really, I think the most exciting part of it is the kind of freedom that you can have to develop and follow your own ideas.
Yeah,
I always kind of had this assumption that you really just you kind of get a job and you do what you got to do in your job kind of thing.
yep, yep,
Which I think you always have to kind of do what you got to do in your job, right? That's part of
exactly.
having a job. But in the startup world, you have a lot more freedom to, if you have a passion for something, just really pull at the thread and see where it goes. And if there's a market and there's a fit and there's demand for it and it solves a problem, you can really take it very far. And that's been a very exciting and surprising thing for me. I think, as I've entered this startup world, is like, oh wow, there's this whole world of opportunities to explore.
You sound like me when I was a naive young person joining a 20-person microprocessor startup, which competed with ARC. And it was
Mm,
kind of like this world of startups in the 90s. Like, what is this? And hey, raising money and, you're doing everything, working 24 hours a day. Yeah. Anyway,
mm.
that's good fun. But so it's quite interesting. You've come to where you are now. You're doing some really good work with Synaptics. So tell us a little bit about the work you're doing with Synaptics. Maybe Pete, you want to just talk about how that relationship.
Yeah, yeah. So I've been we've been, obviously in touch with Synaptics. I've known them for a long time. Um, but what really kicked things off was Dominic Pajak, who's now at ARM. But he actually took some of the Moonshine speech to text models we put out, and he ran them on in pretty, resource constrained Synaptics processors.
Mm.
Uh, and he put together a demo that showed how you could actually speak, have it be understood, what you'd spoken, have it be basically fuzzily matched using kind of LLM techniques, and then take an action. And it sounds sort of dead simple, but
It does
actually,
sound simple.
yeah, but actually, if you think about Alexa and Siri, Alexa is spending $10 billion a year, and like that's the same core problem that they're trying to tackle. I think we all know that traditionally Alexa and Siri have really struggled if you phrase things in the wrong way. So what's really interesting about these modern LLM techniques, like Evan was using in his dissertation, is you can actually recognize a general question, even if it's phrased in a lot of different ways. So
Mm,
if you imagine you have a dishwasher, there's a lot of different ways to ask it, hey, why are my dishes still dirty?
yeah.
Uh, Using LLM techniques, we can actually identify that that's the kind of question that somebody's asking and give the right response. So Dominic did this fantastic job of putting together an end-to-end um, demonstration that on device by using Moonshine models because they're very resource efficient. They'll fit on very small devices. Um, and these modern LLM techniques to do fuzzy matching, you can actually create something that's a very useful local voice agent that really offers a good experience to users. And that's where we came in because uh, we, at the time, we were only offering Moonshine in English,
Okay.
and there are a lot of other languages out in the world, obviously, especially in Asia.
Yes.
So we were able to train models because we're training all our models from scratch. We're not taking somebody else's models, which means we were actually able to train up Japanese, Korean, Vietnamese versions of these speech to text models and integrate them with Synaptics work, um, and even actually offer some text to speech models that fit in with a constrained device as well.
And that was on the Astra processor?
Yes.
I don't know, Evan, if you want to add anything to some of that in terms of, the work you're doing.
Yeah, I mean, I think LLMs have obviously been transformative in just about every space, right? I think um, where they fit with edge AI, in my opinion, is you can either take a small large language model and use the model itself in the application, or maybe you take one of these very large generalist models and then you use it as kind of like a training data generator for smaller models. I think that there are a lot of really interesting opportunities there. They fit into kind of that entire edge framework because they might provide a way in the development process to get the edge ready solution that maybe you otherwise couldn't get because there wasn't data available. So I think there is a lot of different ways that they kind of apply to the space we're working in, both in like maybe we take a smaller model that you can run just by itself on the device and then you use it for the fuzzy matching and things like that. Um, or you use it to train up an even smaller model that you can run in an even more resource constrained environment. That's something that I'm personally very excited about. I think a lot of, as we've kind of adjusted to this new reality of LLMs and the different applications you can build with them, we're sort of just getting started, right? I'm really excited to see once we start um, getting even smaller and smaller and smaller with those models and specializing them. What can we accomplish?
Well, I mean, for both of you, or basically, when we talk about practical ML, you mentioned, some of the work you're doing, but generally, what are the models and frameworks for resource constrained IoT edge devices? You've given the washing machine example. Are there any other examples?
Are you thinking of applications or models or either?
Models at the moment, and we can
Yeah.
talk about applications when we talk about human-centric AI, but
Yeah.
let's talk about the models.
Yeah. So, I mean, I think if you, one of my favorite places to hang out is on Reddit, the local llama forum, uh,
Yeah, yeah.
because that's really where a lot of people talk about all of the different models that are actually, coming out every day. Um, and what's been really interesting with the sort of Cortex A class SoCs that we're doing a lot of work with is they almost always have at least a gigabyte of memory these days. Maybe you get
Wow.
some
Mm.
with like 512 meg, but it's getting increasingly hard to find even low end SoCs with anything less than a gig in memory. And that, plus the speed of, even pretty old Cortex A systems, um, you can actually run a lot of the models that are actually, uh, you know, being run on like desktop machines, anything that's, less than a billion parameters. Uh, which, there are a lot of model releases, like Google's Gemma, and these other models actually have versions of their models which are that small. And for example, with Google Gemma, they actually have a sentence embedding model that's only 300 million parameters. Um,
Okay.
so that's really that's that's really constrained, and from our experiments at least, it's running really well. So almost any model you can think of, um, obviously a lot of the traditional CNN vision models kind of are much smaller than a billion parameters. But even a lot of the more modern models have variants that are, 1 billion-ish parameters. And, they might not run in, 500 milliseconds, but a lot of times waiting 2 seconds for an answer isn't the worst thing in the world,
Mm.
if you can avoid having to ask somebody to set up an internet connection. Um, if you can avoid that, then these smaller models kinda get 80% of the way there.
And I mean, smaller models is one thing, but I think one of the things I keep hearing also is optimizing those models for the specific task. And for resource constrained IoT devices, you can do that even further, can't you? To really make that really efficient. Is that right?
Yeah, exactly, and, one of the things we're able to do with speech to text models is if we know the domain that, the model is gonna be used in, then we can really up the accuracy for that domain. So one example is we work with this awesome startup called Innovative Avionics,
Okay.
and they offer um, voice interfaces for the cockpit for pilots doing checklists. And we actually optimize the models to understand all of the jargon that's in a particular, model of plane.
Yeah,
uh,
exactly. Yeah.
and it's a very specialized set of language. And by doing domain customization, we're able to do a much better job with a much smaller model than if we were just trying to use a general model. Even like the largest whisper doesn't get a lot of the technical terms. So I think you're exactly right. There's this benefit you can get by really having an idea of what you're going to use these models for
Yeah.
versus just kind of trying to create one Uber model that's gonna solve all the world's problems and solve your problem at the same time too.
I think that's the way forward. If you remember, I mean, throughout the history of my history, at least, like you had domain specific things. So it ended up with domain specific accelerators, and you probably end up with domain specific models. And I don't mean the stuff you see on Reddit, but more optimized.
Yeah, absolutely. I mean, I think that we're coming back to the realization that you actually need to understand the requirements of
Yeah.
your application, even if you're using LLM technology to kind of meet those requirements. You can't just kind of grab an LLM off the shelf and expect it to, um, you know, solve everything.
Yeah. Evan, any other thoughts on that?
Yeah, something that comes to mind with this discussion of like generalist versus specialist. When I was doing a user study in my PhD with the smart home LLM project, and I was bringing people in and having them interact with this prototype system that I'd built in the lab. It was basically a smart home that was run by, at the time, GPT 3.5. Um, and you could give it commands, and it would actuate all of the different devices that we had set up in the lab. And we worked through these different scenarios, and one of the devices was a robot, and the scenario was there was a spill on the floor, and so the person gave the command, um, clean up the mess or whatever, and then GPT 3.5 decided, okay, we'll move the robot to clean up the mess. And the user tester pointed out, well, depending on the kind of robot, that's either going to clean up the mess or it's going to make an even bigger mess, right? The robot will go through it and drag it all over the floor, and it'll actually be like a big problem.
Yeah.
So the robot itself is a really important, like, there's not a binary, just turn the robot on or not, and it will fix the problem. There's actually, depending on the context, like, it's very cool that GPT 3.5 at the time could figure out, okay, clean up the mess means turn on the kitchen light and move the robot to vacuum. But the model actually needs even deeper understanding and situational awareness to know, well, can the robot actually solve this problem, right? And I think of that as a good analogy for the specialization issue, because there is definitely a big push toward these very capable generalist models that can kind of just do everything and solve every single problem. But
Yeah.
life, the real world is very complicated, and there's often details that are inherent in different situations that influence what the right decision is. And so, um, I think specialization is going to be very important. People really point at like the bitter lesson every time you start talking about specialization. People will link you to the bitter lesson paper, which basically says that specialization is not worth anything, and just put more data into the model, and that will solve the problem. And I think there's a case to be made for both because even a specialized model needs to have some out of domain knowledge in order to build a good for language, for instance. Like you might train a coding model, might still be trained on like poetry, right? Because it provides this model of language and how language goes together. And so you do need that in there somewhere, but there's a balance to be struck, I think. And so I think specialization is always going to be an important part of solving different problems and actually taking these things and putting them in useful applications for people.
Now, I don't want to labor this point, but I think one of the things I keep hearing is, well, AI is not making any money for everybody. But I have a feeling, this is just my feeling, maybe Pete or you can chime in. This is where I think the real commercial opportunity is from AI on that specialization for specific, you know, for example, resource constrained IoT edge IoT devices rather. So, and I think maybe that's where things might head in terms of, okay, well, VCs think, okay, well, this is where we make money.
I think you're spot on. The economics around AI are obviously very interesting right now, and I think a lot of the generalist model use is kind of subsidized by very massive investment, but that's eventually going to change, and I won't be able to go into ChatGPT and use it for free, all day long, or Claude or any other model, right? I think the economics will shift eventually, and it's expensive at the end of the day.
Yeah.
So I think
Yeah.
companies that can really understand their use case and their users very well and develop something that really solves a very significant problem for somebody and deliver it in an economical way, often that means putting something on the edge and removing the necessity for like a cloud connection and a massive GPU compute to sustain it, right? It's kind of a more economical way of doing it. The engineering challenges are significant, but it's I think good business and people. That's probably the direction that we're moving in. If I had to make a prediction.
Yeah, I was gonna add as well, like, um, talking of bitter lessons, we spent the first couple of years of useful sensors as it was, um, really trying to say, oh, wouldn't it be awesome for your customers to be able to interact with your, you know, TVs or appliances or whatever using voice, and won't they love it? And you know, none of the traditional manufacturers were interested because they're working on razor thin margins,
Mm.
and the idea of doing something that they don't know if customers are actually going to like it, speculatively like that, just, it was a non-starter. But for example, with the dishwasher example, um, a lot of these companies make a lot of their money on warranties. And if that's where most of their profits come from, I believe. And if you send a person in a truck to look at a consumer's appliance because they're having problems with it, that costs the company like $200, and you've pretty much, you've gone into a loss on that. So
Yeah. Yeah.
anything they can do to kind of head off customer, solve customer problems as quickly and easily as possible, without even having to go to phone up a call center, um, is actually, you know, can save them significant amounts of money. So
Yeah.
having a voice assistant that's focused on that versus just this general fuzzy, warm feeling of we're helping consumers, it turns out that that's really important for a lot of OEMs.
Yeah, I mean, it's an extension of I interviewed, at the Goodwood Festival of Speed, a McLaren engineer a couple of years ago, and, he was talking about how they need to know about the problem before the customer does because they're spending like $200,000 on this car. They need to know specifically on that tire, on that thing and they will then fly in people to make sure that specific thing is fixed with the right parts.
Yeah.
I mean, it's an extreme example, but I think that's kind of where this fits. I mean, in terms of human-centric AI, yeah, what are the modalities for everyday interactions? Why do they matter? Why they matter the most? And designing for on-device learning. I mean, again, refer to some of the stuff you've been doing with Synaptics. It'd be quite useful to understand some of that.
Yeah, so one thing I hear from a lot of people is, um, oh, voice interfaces just aren't, you know, like they're not a good kind of modality for interacting with things. And the question I usually ask them is like, well, when you're sitting next to your significant other on the couch and trying to decide on a TV show, do you text them or do you talk to them? And apart from a few, I sort of
I call my wife.
yes, send a telegram. Yes,
Yeah. Oh, even a fax. There you go.
yes.
Anyway, sorry.
No, and apart from a few sort of Gen Z people, like almost everyone's like, well, of course I talk to them. And you ask them why, and it's like, well, it's a lot faster, it's a lot more interactive, a lot more natural. And that then leads me back to like, well, then the problem isn't that voice interfaces don't work. It's the problem is that our voice interfaces aren't good enough for understanding and responding um, to people. And so really our job as engineers is to figure out how to do it better.
Yeah, obviously that's interesting. And in terms of that voice, so that's kind of where you've focused on, isn't it, with Moonshine and with Synaptics?
Yeah, exactly. Because again, I'm a strong believer in people will like voice if we get it right. And this is an opportunity to take a fairly constrained problem, like helping people with their like appliance problems, and really focusing all of the latest research and learning from all of the stuff Evan's done, and just really try to perfect that one experience.